In this video, we're going to take a look at an introduction to multiplying monomials. Through that, we're going to see the multiplying powers rule as well. So we're first going to be looking at an expansion model. So for example, we're going to be simplifying all day. If we have this, I've color-coded each of the factors so that we can kind of see what's happening as we go through. We can use the commutative property of multiplication and rearrange the order we're multiplying. So I'm going to rearrange and have my coefficients at the beginning and then my variable terms second, or variable parts second. Then I can go through and multiply. 4 times 3 is just 12. X times x gets me x squared. Let's look at a similar one now. The only difference here is our first factor is an x squared factor. But again, I'm going to write it out, expanded, rearranging the order in which we're doing it using the commutative property. The 3 times 4, again, simple, it's going to be 12. But I'm going to go one step further and I'm going to actually expand that x squared out again. So now I have that being x times x, because now we can really clearly see what's happening with the variable parts. X times x again gives me x cubed. In general, whenever we're multiplying monomials, we first multiply the coefficients. Second, we multiply the variable parts, and in order to multiply the variable parts, we add the exponents on the like variables. So this is what the product of powers rule is. You have similar bases or like bases, then you add the exponents on those like variables. So let's try a couple examples skipping that expansion step. So this time I've color-coded it so that my coefficients are one color and my variable part is another color, just so we can kind of see what's happening. So we're going to start by step 1, multiply the coefficients. 5 times 7 gives me that 35. Then we multiply the variable parts by adding the exponents on like variables. In this case, both variable parts are just x, so we add the exponents to get x to the power of 5. Let's try one more. In this case, I don't actually have a coefficient that I can see on the first term. Remember, there's always an implied coefficient of 1. So 1 times 8 gives me 8. And then x cubed times x to the power of, again, there's an implied power of 1. There's an implied exponent of 1. So we get x to the power of 4. Now if we step it up a notch, and we look at an example like this. Now we've got 3 different colors because I have a second part to my variable part. Now I have x and y going on. So again, I'm going to start, first step, multiply the coefficients. 2 times 7, 14. Next step, multiply the variable parts. It says add the exponents on the like variables. So I'm going to look at the x's first. X to the power of 5 times x to the power of 3 gives me x to the power of 8. Then I'm going to look at my y part. Y to the power of 4 times y squared, y to the power of 6. Last one. Only difference here is now we have a negative. Again, we're just going to think about that when we're multiplying those coefficients. Negative 4 times 9, negative 36. Now when I look, my colors aren't in the same order because my variable parts are in a different order. The order that I want to write my terms in is always alphabetical, or the order I want to write my variable part in, I should say, is always alphabetical. So a first. A to the power of 3 times a squared gives me a to the power of 5. B second. B squared times b gives me b cubed. That's all for today. Again, remember, you can go back at any point and write any of those into your notes.